and thank you for attending today's webinar, Doubling FWA Network Capacity with Self-Installable Wireless Window Mount Outdoor CPE, sponsored by Solace. Before we begin, I wanted to cover a few housekeeping items. Under your slide view is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your question to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the Resource List widget. Also on your screen is a survey. Please take a moment towards the end of today's webinar to complete it. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. Now I would like to turn the event over to Gabriel Brown. Gabriel?
Good stuff. Thank you, Barbara. And hello and welcome everybody once again to today's session, Doubling FWA Network Capacity with Self-Install Wireless Window Mount Outdoor CPE. It is terrific to have you with us. Thank you very much for coming. We're here, of course, to talk about fixed wireless access and the customer premises equipment, the device you install at your home or office to get connected. This is a good topic anytime, but today it's actually a little more exciting than that. So stay tuned for a really interesting session. We know, of course, that because of building entry loss, attenuation through windows and walls, that outdoor CPE perform much better for the customer and the network than indoor devices, but they're also harder and more expensive to deploy, less convenient. And so the focus of the session today is on a solution that mounts either side of a window pane and doesn't require a drill or a cable, and therefore can be self-installed by the customer. Obviously more convenient, better economics, and so forth. And Solace are going to explain, today's sponsor, are going to explain how their R&D in wireless power makes this a viable and attractive model. They're also going to set out some of the technology and market development work they've done to support this. So stay tuned, it's really interesting. We have a bunch of material, but some really great speakers to take us through it. My name, as you heard, is Gabriel Brown. I'm an analyst with Omdia, where I cover wireless access networks. That's included a lot of FWA work over the years, of course. I'm your host and moderator for today. I'm joined by 3 expert guest speakers from Solace, who've put together a fantastic presentation. So first of all, I'd just like to introduce Dan Goossens as the first speaker. Dan is VP Sales and Marketing at Solace. Dan, welcome to the event here. Just please introduce yourself and tell us a bit about who you are.
Thanks, Gabriel. So I'm Dan Goossens. I lead sales, marketing, business development for Solace. And at Solace, what we do is wireless power. And wireless power may sound vague or a concept that's been around for years, but we've been doing that for about 15 years. And we're excited to tell you a bit more today about how wireless power can unlock some real benefits for the fixed wireless access industry.
Yeah, good stuff. Really looking forward to it. But so just for the audience to understand a little bit about what Solace is proposing here. You are not and don't intend to be yourself a CPE vendor. Is that correct?
Correct. Yeah, we don't build CPE. We're a one-trick pony, and we're really good at that one trick, and that's wireless power. And so we typically look for applications where wires or wired solutions or connectors really hold back innovation. And so we've done that for helicopters, subsea sensors, and in automotive industry as well. And so really what we do then is really lead the way and show the market what's possible when you have access to a technology like wireless power. So really, we're an enabling component that can really let CPE vendors take innovation to the next level and deliver much more value to operators in the end.
Yeah, okay, good stuff. We're going to hear from Willem and Maya in a moment about how you've sort of put together that proposition. But just before we get into this, now this idea of a window mount CPE is not a new one. It's been around a little while. Have you got anywhere with this? Are you proposing here like an idea that you're hoping people pick up? Do you have any kind of, for want of a better word, any traction, any partnerships or any sort of ongoing activity here to?
Yeah,
you can tell people about?
Absolutely. Unfortunately, we are bound by a lot of NDAs at the moment, but in general, what I can say is that there are several operators currently trialing solutions that are either built by Solace or that Solace has built in partnership with some CPE vendors, and we are looking to announce some major partnerships over the next few months.
Yeah, okay, good stuff. I think when people see the material, they'll understand that this is quite a well-developed proposition, but just want to kind of set the table correctly here. So with that, thanks, Dan. I'm going to next ask Willem Verbiest to introduce himself. Willem, could you say hello and let us know your background?
Yeah, thank you, Gabriel. I'm Willem. Good morning, good afternoon to everyone. I have a long history in telecommunications, both on the fixed access side as on the wireless side, in particular in fixed wireless access. I was part of the first 5G fixed wireless access commercial deployments roughly 7-8 years ago by now. And I'm very excited now to work with Solace to give another boost to 5G fixed wireless access.
Fabulous. Thanks for joining, Willem. And so obviously, Willem's got a lot of experience in the access space in general, in fixed wireless as well. Also, I checked his LinkedIn. He's be too modest, but he's just been awarded an IEEE Milestone Award. In fact, the team he was on for their contribution to developing, inventing ADSL, I think back sometime in the 90s or so. So, you know, Willem won't mention it, but I did notice that on your LinkedIn, Willem. Thanks for joining. We're great to have you. So next, Maya Sarod. Maya, if you're there.
Thank you, Gabriel. Hello, everyone. We are very happy and excited that you have joined this webinar. I've been working in the networking industry, specifically home networking, for over a decade, seeing the development of Wi-Fi 4 to Wi-Fi 7, looking forward to Wi-Fi 8 and other home networking technologies. And at Solace, I'm very excited to work in developing efficient data communication, reliable data communication with efficient power transfer, wireless power transfer systems. And today, I'm happy for the opportunity to present some real data on our window mount solutions, which will unlock the key benefits of a fixed wireless access system. Thank you.
Okay, fabulous. Thanks for joining, Maya. And you can see all the bios and things. You'll see Maya's had roles in different vendors and component and ISP companies as well through his career. Final thing to say, all three speakers are very open to questions, technical and business related. We have a ton of material. We're going to pause in between the sections, see if there's an appropriate question. If not, do some Q&A at the end. Please feel welcome and take advantage. I'll be monitoring that on the back end as we go through. Very quickly on the agenda, I've got a super short introduction. Willem will then give us a view on the pros and cons of outdoor versus indoor FWA solutions. Dan will take us through the wireless power part of the presentation before Maya takes us through the what's called wireless power and data architecture, how you sort of essentially create a solution through the window and into the home. So, like I said, the Q&A at the end, but we will do some in between these sections if appropriate, if we can keep to time. I've only got a minute or two for this slide of introduction. I think it pretty much speaks for itself. What I'm showing here is our latest forecast for FWA in terms of subscriptions and revenue over the next few years. It's only just come out, actually, and so it's pretty fresh data. You can see over the forecast period here, so we're looking 6 years forward from 2024. We're more or less going to be getting a doubling of revenues and subscriptions. It's a little less than a double, of course, on a 5-year view, but there is strong growth. Clearly from the chart here, a lot of that is from 5G. One point I did want to make, and you can look at the forecast in more detail in the slide download. Classically, we'd think if you have FWA where wireline wasn't available or was too expensive or so forth. But I think what we've seen, as the market's evolved over the past few years, there are many reasons why people choose an FWA solution. It can be across different pricing tiers. You get different types of customers, whether that's enterprise or residential. The service tiers themselves can be a very basic, sort of best effort, low cost service, right through to gigabit and high performance. And, it used to be a kind of rural or edge of suburban type play, people would think of it. But actually, the urban market is just as active, maybe more active in many cases as well, simply because of the convenience. And, people have different reasons for choosing this type of service. It's all really had a massive boost through the sort of maturity and scale economics that have come with 5G over the past few years, and which we really, we're in a great place now for that to continue to ramp through the rest of the decade. So I'm going to hand over to Willem to take us through the first section. Willem, please.
Thank you, Gabriel. Indeed, fixed wireless access, 5G fixed wireless access has been hugely successful. And let's have a look at the root cause why it was so successful over the past decade, roughly. And first of all, it's all about agility. As an end user, you order service day one, second day you get a parcel, you plug in the box and you're up and running. So that self-installation together with the agility has been a key component, and it beats other access technology big time because of that. And then also 5G has proven to provide a decent performance and network capacity in good conditions. And that comes because of the 5G technology itself, but also to the quite large chunks of spectrum that were assigned to 5G and that are in use across the world. But there is a bit of a snag here. It says in good conditions, and that's where the home plays a key role. If the 5G CPE is placed in a good position, you're going to have a good link budget and you're going to have a good throughput and efficiency. However, if the CPE is not in such a good position, then this could be a significant drag on the performance for the end user, but also on the network. And for instance, if I can refer to a study of Nokia a few years ago, they showed that between a good position and a bad good position, there could be a delta of, say, 7 dB in link budget. And very important, that gives an impact of roughly 30% on the network capacity. So 5G fixed wireless access being hugely successful, it now risks to become a victim of its own success because network capacity may dry up. And that's why efficiency is more and more important. It can get even worse if you're living in a house with low E windows or low energy in general. Then the wall and window attenuation can further degrade the signal. And in many places, actually, 82 windows, for instance, they give roughly a 30 dB loss. In Europe, there's plenty of these type of windows. If you look at North America, roughly 25% of the homes has these type of windows. And to make things even a little bit more worse, there are quite a lot of places where insulation has aluminum foil on the outside, which basically makes your house a pretty good Faraday cage. Let's get practical. Just let me give you a sample of all these things just to give you a good feeling. I did some measurements on my house. And I was using a 5G CPE, which I could mount either on the outside or on the inside of a window. And that window was pointing to the base station. And you see outside versus inside gives a delta of about 26 dB in signal strength, RSRP, and around 20 dB in signal noise ratio. And that has a huge impact. You can see when the device is outside, I get more than 700 megabits per second, while if it's on the inside of the window, I get less than 300 megabits per second, a 60% drop, and even the uplink itself is even more affected. Now, you could argue, look, 300 megabits per second, that's not a bad service, and I do agree with that. But the key thing is that if I'm working in conditions with a 10 dB signal noise ratio, minus 115 RSRP, I'm consuming much more network resources than if I'm in good conditions. I'm consuming much more resource blocks, much more spectrum, much more time slots. And that has a huge impact on the network capacity. So literally, if everyone would be in the same conditions and if everyone would move from inside to outside, you would have a gain of more than 60% in network capacity, which is really important as networks get very, very busy. The impact on the end user is, of course, the performance can degrade and can be inconsistent, but I think the most important impact is really on the operator. It's being indoor in bad conditions reduces the network capacity very significantly, reduces the coverage, and quite a lot of operators had to install customer caps, not everywhere, but in busy cell sites. And it has also a direct impact on the profitability of the service, because if you can connect less customers to the same fixed cost, to the same network cost, obviously that has a very significant impact on the return on investments. How are operators dealing with that for the moment? Well, one part is you can further densify your network, which is obviously very expensive. And other thing you can do, you can use more complex CPEs with 6 receive, with more uplink power, etc. But that's all fighting the symptoms. It's not addressing the root cause. And the root cause is really the home environment. Give you some more numbers here. This is from an Ericsson study, and it shows that if you move 20% of the CPE, which are in relative poor position, if you move those outside, you gain 60% in network capacity, very similar to the measurement I did. And why is it so significant? Well, if you look at the curve of the spectral efficiency improvement, and spectral efficiency is a measure for how much throughput you can get in a given spectrum asset, let's say 100 megahertz of N78. That improvement is by far the largest if you're in relative poor conditions. For instance, if you go from 0 to 5 dB SNR, the improvement will be much, much larger than if you go from 25 to 30 dB SNR. And that also indicates where the easy wins are going outside. It's in the first place in suburban areas, also rural, but also obviously in dense urban or urban areas, you also have plenty of metal-coated windows, which are a target for this technology. At Solace, we did last year, we did a trial, let's say maybe more a sample. We tested at 20 houses spread over Belgium and Canada. And the results are, I think, quite significant. First of all, in 25% of homes, there was just no indoor 5G coverage. While if you go outdoor, you could still get minus 95 to, let's say, minus 105 dBm RZP, which is pretty good signal level, which can provide a good service. So 25% of the homes were enabled by going outside. In all houses, there was a more than 100% uplink improvement. 100%, that means times 2. It's to be very clear. And in general, in most networks, it's the uplink which is the most constrained. And how comes? That's because of the asymmetry of 5G. The base station can blast much more power than a CPE can. You have the 80-20 tag, and you have the MIMO, which is much more advanced in the downlink than in the uplink direction. So good conditions for uplink are really important. And then if you look at the houses which were, let's say, at not yet at the cell edge, but let's say at minus 100 dBm or worse, there we saw an uplink improvement of 200%, which is times 3, to be clear, and a downlink improvement of 50%. And again, this is about the network capacity. You can connect 50% more users to the same network. So, long story short, there's a lot of evidence that outdoor fixed wireless access is so much better than indoor, but there is always a but. Today, if you do outdoor fixed wireless access, typically this comes with a truck roll. It's very expensive. Well, depends a bit on the region, but it's expensive. and it breaks the agile model of fixed wireless access, which has been the key of the success so far. So, wouldn't it be great if there was a solution that was fully self-installable and that would have a 5G modem on the outside, and with all the benefits of being on the outside, the throughput, the capacity, the coverage, and having a Wi-Fi gateway on the inside that can serve the home, has good coverage throughout the home, and connects wirelessly to the outdoor. And very importantly, the outdoor unit without any wires attached, and that's why we call it wireless window-mounted outdoor CPE, and where the installation is as simple as sticking a box to the outside of the window, matching it with an indoor unit on the inside of the window, and putting in a DC plug, and the service is up and running with all the advantages that I have been talking about so far. What is now the core technology to enable this, and what are the key enablers for this? Well, the first one is a very mundane one. It are windows. Windows are, as far as I know, on every single house in the world. And windows, they provide an excellent surface to do self-installation of devices on it. I mean, in a brick wall, you have to drill. In a wooden wall, you have to screw. On a window, you can attach devices very easily. And a key technology that enabled that is the gecko tape. Has been around for quite some time, provides strong adhesion, is fully weatherproof. We have it running in Canada for over 2 years in harsh conditions. And also very important, you can remove it without breaking anything. You could possibly glue things to a window or a wall, but if you can never remove it, it will not be acceptable for end users. And then finally, to enable an outdoor unit without any wires connected to it, you need two technologies. First is you need wireless power, and Dan is going to tell everything about it in a few seconds or minutes. And then second, you need an unconstrained wireless data connection between the outdoor unit and the indoor unit, and Maya is going to talk about that. But maybe it's the moment to take a deep breath and maybe take some questions. Gabriel?
Yeah, nice one. Thanks, Willem. So I guess my first question to you is, when you've been discussing this with peers in the industry, prospects, customers, that kind of thing, obviously you're well known in the industry, as established. What's the reaction been? What kind of things are people asking you, or what is there anything that sort of stands out? They're like, hey, what about this?
Yeah, well, interestingly, last year we were at Network X, and this year we were again at Network X, and the feedback has evolved a lot. I think at this moment, I think it's clear for many operators that outdoor is definitely a better proposition than indoor, and that the proposition of a two-box solution on a window looks to be viable. Of course, it's all in the details. So there are many types of windows around the world. We've done some analysis on that, and for instance, what we have seen is that a fully wireless solution will be twice as successful for self-install than if you would have a solution with a thin wire going through the seams of a window. So I think the perception has matured a lot over the last year.
Yeah, I've seen a few of those thin wire products, but you kind of, I don't know, like you're going to have your window cracked, or I don't know about that so much. I like this. This looks more elegant anyway at face value. Thanks, Willem. So Willem's with us for questions. I'm going to hand over now to Dan for the wireless PowerPoint. Before we do that, keep questions coming in. A lot of people are commenting they couldn't access the slide download. These are in your console. If it's not there, do a browser refresh and they will appear. Maybe don't all do it all at once, just in case something goes wrong. But if you do it over the next few minutes, a quick F5 and you'll be back into the call. With that, Dan, please take it away.
Thanks, Gabriel. So Willem introduced the technologies needed, and one of them, of course, is wireless power, which is really our bread and butter. And that's what I'm going to be talking about and introduce a little bit more about what this technology actually is and what it can do and why it's different from the wireless power technologies that you're currently familiar with. So basics first, what is wireless power? Well, it's energy transferred from point A to point B, from a transmitter to a receiver. And typically on both sides, what you need is some form of electronics and a coil, because we're using the principle of magnetic induction for wireless power transfer. Where you see this today a lot is in your wireless phone charger. Most people have used this product before. It's all around us. And I would say that it's not one of the most impressive implementations of wireless power. It requires perfect alignment, and even with the latest standards and improvements, you can only get up to 25 watts over 2 to 3 millimeters, and any misalignment or any distance significantly degrades what's actually possible. So this technology, is it really fit for use in a window mount CPE? It's not really. And so really what we've developed, and we've taken a really bold position in this, is that we've decided to make adaptive power transfer. And this was a decision made 5+ years ago, where common wireless power systems have an optimal point of operation. And that optimal point you can control in a lab when all the variables are perfectly controlled. There's no real world things to throw it off. You can get really good performance, and a lot of things are possible. But then as soon as you put that in the real world, delivered energy drops, because there is different transfer distance, there is some misalignment. Maybe there are metal coatings for energy efficiency in the window if you deploy it on the window. And so really what we focused on is a technology that can handle all those variations very elegantly without the need for additional components and tuning, because all of that adds extra cost, and we know we play in cost-sensitive markets. So really, we focused on building a system that can handle whatever is thrown at it. And here's just a very quick demo video. This is the demo we take on the road with us all the time. But you're seeing power transfer from the right to the left, where we're illuminating that LED. And you can see the transfer distance and misalignment tolerance. And so this unit itself, for example, can deliver more than 15 watts of power. Now, how does that actually apply to CPE and the outdoor window mount that Willem introduced? Well, if we look at the key requirements, number one is you need to deliver sufficient power so that you can power the outdoor 5G module and also the data link back inside the home. What we see typically is that takes about 20 watts, 15 watts or so for the 5G module and 5 watts for the data link through window. It should also work with the majority of windows, because I don't know about you, but I don't really know what type of window I have in my home. I know it's double pane, but I don't know exactly how many layers of silver coating I have, for example. So this needs to be something that can work with the majority of windows without a user intervention. Because if you're an operator and you're deploying and you need your customers to tell you what type of window they have, and then you can send the specific SKU, that also ruins all the benefits that we're proposing. And then for installation, it needs to tolerate misalignment. You don't want the system that you need to perfectly align to the millimeter and maybe have very strong magnets that snap it together. All these things add friction and cost, and we don't want any of those things. And then the fourth thing, of course, you need to deliver sufficient throughput through window, because it doesn't matter if you receive a better signal outside. If you kill it by making it go through a low-E coated window, you're no better off. So if we take those requirements in, what are some of the variables out there? And so we've done a lot of research on different window types globally. And this is a distilled version. There are two things that you should take away. One, there are different types or numbers of window panes. It ranges from single to double to triple pane. And really what that means is a window can be as thin as 2.4 millimeters and as thick as 51 millimeters. So right away, for example, you know that your wireless phone charger is not going to work because that only transfers power over 3 millimeters. So you can only deploy it on a single pane window. And just to give you an example of how common these types of windows are, we've taken a sample of the US, but all of this is available for Europe and other locations as well. In the US, as an example, 65% of windows have double panes, so 2 panes of glass. So right away, the wireless phone charging technology would not work for the majority of windows in the US. In Europe, double and triple pane are actually quite common. Single pane, generally not so much. So that's one variable on the Windows side of things. There is a second one, which I've referred to a few times. It's the type of low-E coating. And a low-E coating is really something that's applied. It's like a thin layer of metal or metal oxide that's placed on one of the window surfaces to improve the insulation piece. And there are different variations of that. There's a hard coat, which is not that impactful for wireless power and RF signals. But then what is impactful are the layers of silver. And that can be done in single, double, or triple layers of silver, which we sometimes refer to as AG1, 2, or 3. And every additional layer of silver has a meaningful impact on both wireless power transfer and attenuation of the RF signal. And so really what you need is a system that can handle any permutation and any combination of these window types. So again, an example of how common is this in the US. And in the US, for example, you have about 25% of windows have a low-E coating, a soft coating. But even more importantly, of all windows sold today, 85% of those have a low-E coating. And this number is much higher in European countries, for example, where the energy efficiency standards can be a bit more strict. So really, this problem is only going to get worse. And we've seen a significant correlation between low-E coated windows and some of the results that Willem showed for actually really impacting the fixed wireless access network. So the module we've developed is the Nova 30, which you can see here. And back to Gabriel's question to beginning, we don't develop CPE. What we develop is this module that can go into CPE. And so we partner with CPE vendors to bring this innovation to the market. This module is the Nova 30. It leverages our magnetic induction technology, can deliver up to 30 watts through Windows. And that can work with one SKU for 98% of global Windows. So the vast majority of all Windows globally really can take advantage of this single module. It can transfer over 40 millimeters of distance, and it also has automatic window optimization. So once it is installed, it detects what type of window it's dealing with, and then it optimizes the performance to make sure that you have stable output, power output on the outdoor unit. Just to give you a sense of dimensions, this is roughly 8.5 by 8.5 centimeters in surface area, and then 3.5 centimeters thick. There are different configurations possible. It can be a side-by-side or a stacked configuration. There are a lot of customizations possible. And even though this module is limited to 30 watts, it is possible to deliver more power through a window. And the way we do that is by increasing the size of the coil, which you can see on the bottom module there. And so we've done some testing and verification, and really we can get up to 90 watts through Windows. And we know that some systems, specifically the LOE type systems, those receivers need a fair bit more power. So that's a possibility as well. And some test data, we have a whole slew of windows in our lab. We've collected a sample that's representative of what you can find out in the world, all the way from some of the simplest plain glass to double and triple panes with several low-E coatings, silver coatings. And so on this chart, you can see, as indicated by the red line, the requirement for power delivery to the outdoor unit. And then in the blue bar, you can see what the peak power is that we can deliver through each of those units. So you can see that we relatively comfortably can meet all the power requirements for any different type of window. Then the last part really is misalignment tolerance. And this visual shows how tolerant to misalignment the system actually is. So 10 millimeter misalignment is perfectly fine, no degradation of performance. Same for 20 millimeters misalignment. Really the drop-off point is 30 millimeters of misalignment. But remember, we're talking here, this is 30% of the device being misaligned. And that's quite a lot. In all of the testing and verification that we've done some friendly user trials, for example. we see that there's virtually no issue with this because it is so visually disturbing when you have it that misaligned that nobody really accepts it from an aesthetic point of view, let alone from a power delivery or performance point of view. So really the key takeaway here is it needs to be severely misaligned, almost purposely misaligned before it stops performing. So really just a quick recap in terms of the requirements for the outdoor CPE application. We can deliver 20 watts outdoors. It works on the majority of windows, 98% of global windows, and it can tolerate significant misalignment between indoor and outdoor units. The fourth remaining point, of course, is on the data side of things, which, with wireless power, we can transmit some data, telemetry data, but for fixed wireless, we need much, much more. And that's what Mayur is going to cover in the next chapter.
Thanks, Dan. So we had a few questions in. Some of those we're going to get to in this last bit. Somebody's written in to say, yeah, that works out about the size of a beer mat for anyone who's wondering how big these are. So thanks to that person for writing in. I think we can all picture that pretty well. Dan, we do have a question from a European operator. By the way, I won't give your name or company name when we read out the question, so you can do it on that basis. But since you mentioned it, Dan, the question is, did you evaluate the option to attach the outdoor unit to the indoor unit with magnets instead of using gecko tape? You mentioned magnets there you didn't want to use. Just go through that logic a bit.
Yeah, really, in terms of the reliability, the magnets, they need to be quite strong, and the strength of the magnet is also dictated by the window type. So by using gecko tape, we essentially remove that variable of, how thick is the window, etc. And we're really seeing that gecko tape is already being widely deployed for this use case in that exact form. There are some devices already mounted with gecko tape, and its performance is incredibly reliable. So we want to make sure that it's perfectly aligned. The other benefit, of course, is with gecko tape, you decouple the timing of the install. If you have a magnet, you need both sides at the same time. With gecko tape, you can install the outdoor unit, whatever you need to do, and then attach the indoor unit at a different time. So there's a lot of benefits of the gecko tape.
Yeah, okay, good stuff. So we'll come back to some more questions in a minute. We've got this last section. Someone's asking, Mayur, you're going to take us through this. We have a question from an ISP in India. This person's asking what protocol is used to form the communication between the outdoor and indoor unit, which I think cues you up very nicely here, Mayur.
Exactly, Gabriel. Thank you. Thank you, William and Dan, for the great presentation. We have learned the benefits of putting a 5G receiver outdoors and our groundbreaking wireless through glass, power through glass technology. In this section, the final section of the webinar, I would like to present some data communication technologies. I see some questions coming up about networking and data communication, which I hope to cover through the section here. And to answer the question, Gabriel, we have two Li-Fi and Wi-Fi, which we will briefly cover for the through glass technology for data. Before that, so I would like first to run you through different possible CPE configurations an operator can think of deploying this window-mounted solution. So that really depends on the operator's strategy and how they want to enable customers. And it's all dependent on the number of CPE devices that will bring internet to a user in the home. So here you can see the simplest ready to go to the market solution, which is a two-box solution, where you have the 5G receiver with an integrated data module inside in the outdoor unit. And inside in the indoor unit, you have a Wi-Fi gateway, which basically a residential user can connect over Wi-Fi. If there are some legacy gateways in the home, we can also think about three-box configuration, where you have again the 5G receiver with a data module in it, and basically the indoor unit just has Solace Power transfer system, and then a gateway which is connected either wirelessly or wired to the indoor unit or the 5G receiver outside can use to access the internet in the home. Finally, something which will not look in this presentation is the universal four-box solution, which is meant to be used for fixed deployment, such as a roof-mounted 5G receiver or a LEO satellite on the roof or a pole mount 5G receiver, where you can have this four-box solution where the outdoor unit can power the outdoor 5G receiver with power over Ethernet. And there is a very high capacity data link between the outdoor and indoor unit over Wi-Fi or Li-Fi. Coming back to the question about the data technologies, Solace Power has worked with both Li-Fi and Wi-Fi. So actually we have partnered with Pure Li-Fi to build a links bridge platform, which can deliver up to 1 gigabit of data to glass over Li-Fi protocol. Right, and this is all while we are simultaneously powering the outdoor receiver. In today's presentation, we would like to go through a POC that we have made, which shows a Wi-Fi 7 system, which could deliver up to 3.5 gigs data link to glass. And all of this was while we were powering the 5G receiver, a Wi-Fi tri-band gateway outdoor through our technology. I would like to first begin with a simple install scenario where you have this two-box single hop. The single hop means that a Wi-Fi client just needs one hop to get to the internet connectivity from the 5G base station. So in this architecture, you can see that the outdoor unit consists of a 5G receiver, a dual or tri-band gateway, and Solace Power to glass receiver. On the indoor side, you just have the power transfer module from Solace, which powers the outdoor unit. So this is a very low cost, simple to install. The measurements in our reference home on a double pane, double coated metal glass, we have seen we could achieve up to 500 Mbps within the same room. So now that all depends on the type of window on which this two box is installed and the proximity of the user to the outdoor gateway. So there is no doubt that the Solace Power through glass technology can handle the peak currents and loads for the Wi-Fi, dual band or tri-band Wi-Fi gateway and the 5G receiver. But as a system architect, considerations have to be made on the power dissipation and the footprint of the outdoor unit, because the outdoor unit needs to be waterproof. So that's something which has to be considered while doing this deployment. Next, I would like to go to the three-box dual hop scenario. So this is the scenario where we touched upon the user has a legacy, has a Wi-Fi tri-band gateway in the home. And this system would basically connect to the indoor Wi-Fi gateway over a Wi-Fi stay connection. So this basically reduces the power consumption and the requirement for the outdoor unit. So as you see here, the outdoor unit is a 5G receiver, a 2x2 Wi-Fi stay, and again our power transfer receiver module. And indoor unit is again just a simple power transfer transmitter. So this is this is a very small form factor for indoor-outdoor unit, and the Wi-Fi stay connection basically makes a WAN connection to the indoor Wi-Fi gateway. Again, you can expect to have above a gig throughput, but it all depends on the positioning of the existing Wi-Fi gateway inside the home with respect to the windows. So that's a factor which will play with on achieving the peak throughput. And to solve that, we have the ready-to-market solution, which is the two-box dual hop. So in this scenario, basically you have the Wi-Fi gateway mounted on the glass indoors. And the outdoor unit is again a simple 2x2 Wi-Fi stay and a 5G receiver. And with this system, we have measured more than 3.5 gig through a double pane metal coated glasses. So there is in this scenario, you don't have any throughput constraints. The form factor of both the outdoor-indoor unit is small. The operator can choose to deploy a tri-band or a quad-band gateway and split the 6 gigahertz and 5 gigahertz band for the window link. The only thing that needs to be considered is that the Wi-Fi gateway is not central to the home, which actually is not the case also with your DOCSIS or with your fiber modem, because you are limited with where your cable comes in the home. So there might be a coverage, the coverage issues for the far edge of the home. But that all depends on the placement of your Wi-Fi gateway. Another thing to note is that for the window link, you don't need a very high power because we are not constrained by the link budget. So even with our 10 to 15 dBm EIRP, we have shown that we could achieve 3.5 gig over a Wi-Fi 7 link. So finally, we would like to present our proof of concept. So this is a demonstrator completely built from off-the-shelf Wi-Fi 7 reference platform. So you see here, there was a question on the size, but the size of the box is only 15 cross 10 cross 6 centimeters, not very big, and it's very light. And it is mounted by gecko tapes on a window. And we would like to show you some results in the next slide. Just a note that this system integrates a standard 4RX2TX 5G modem and 3x3 Wi-Fi 7 radio. So we did some tests in a reference test house in Europe. The house was specifically built with bricks, and it also had some aluminum foil within the walls to protect from heating, to provide insulation and moisture protection. So all of that played into a poor RF signal inside the home. And for some reference test, we measured at 4 locations inside the home, where also to note that the 5G, the window mount outdoor unit was placed at location 0 on a double pane metal coated glass. And on the south side, you had triple pane metal coated glasses. So these are really tough windows and a tough environment for both for 5G penetration. First, I would like to present you the through glass data link. So here we did a speed test between the outdoor unit and the indoor unit, and we could consistently achieve 3.5 gig with a 3x3 on a 320 megahertz Wi-Fi 7 system. And just to note this, just to remind you again, the outdoor unit is powered wirelessly by our solution, so it could handle the peak load for this 3.5 gig through glass. We also did some end-to-end throughput testing to show you that it is possible to achieve a 1 gig throughout the home. So just to note here, the through glass link was on 6 gigahertz, and the indoor home link was on 5 gigahertz. And we could consistently measure up to 900 Mbps. So we were limited by the 1 gig Ethernet port speed. But throughout the home, we could achieve up to 900 Mbps and more. That's all based on the speed that will be provided by the 5G network. Last but not least, Dan touched upon the misalignment, how we are tolerant to any misalignment. So we did some tests by misaligning the indoor-outdoor unit by up to 2 centimeters. And still we could wirelessly power the outdoor unit and measure up to 2.5 gig on the window link, on the Wi-Fi 7 link. So also just to note, our trials have shown that a 2 centimeter misalignment is easily visible, and customers try to correct that by placing it, having a better alignment. So we think misalignment would not be a problem with our technology. Finally, the holy grail of the fixed wireless access is that we can deliver on the required power for the 5G module and the data module, which is Wi-Fi in this case. And our solution works on majority of window types, as we have covered before. We are tolerant to misalignment by user, and there is sufficient throughput with the Wi-Fi 7 to deliver up to 3.5 gig through glass. Thank you, and we are happy to answer any questions.
Gabriel, I think your mic is broken there. There's some significant distortion, but maybe I'll jump in and take over. Mayur, we got a question. Have we considered using a laser transmitter receiver pair to transport data between ODU and IDU through the window?
So we have used Li-Fi, which is light communication, to do up to 1 gig. And I think the challenge was to have quite a wide bandwidth, so have a 1 gig throughput and more. So I'm not sure with laser we have that capacity. And also we were more invested on protocols which are established, such as Wi-Fi and Li-Fi, to develop our solution.
Great. Still mic issues, Gabriel. I saw a few questions come in as well, asking, and rightly so, about the price of all of this, because of course it all is great, but if it costs $1,000, it's a no-go. And really, we're working quite closely currently with several CPE vendors and operators on that business case. It's looking like the business case is feasible, especially if professional installation is the alternative. In terms of the additional cost, we're not talking about hundreds of dollars. We're talking about tens of dollars. So it's something that we continue to work on as well, as we're targeting deployment of these devices in the next year.
You've got it down. If you can hear me, you've done a great job. So.
Okay, you're back.
Oh, okay. Here's a quick one for you. What OEM vendors are you currently working with, and when will some prototypes be available for testing from a US provider? That one.
Yeah, we're not quite able to tell you yet who we're working with. There are, let's say, a handful of the leading vendors we are working with, and we expect to have. Of course, some operators already have prototypes that they're testing, but we do expect to have more prototypes more widely available early on in January, if not before Christmas.
Yeah. Okay. I think you've done the cost questions. I think I heard that. Perhaps this would be a good one for Willem. Or Maya, let's try Willem first. Can I ask what percentage of these in-out devices do you think will not be successful for self-install and will need a follow-up truck roll? I appreciate that's something you're only going to really understand through actual field data, but do you have a feel for that already, Willem?
Yeah, I would say 90% plus successful. And why do I say so? Well, you have seen, for instance, the resilience for misalignment. We have looked at all the various window types in the US, including fly screens and so on, and in Europe. So we believe that putting these devices on the windows is so simple that roughly 90% will be successful. One thing to add, though, this is about putting a device on the window. Obviously, there's another point is putting on the right window. If you will put it on the window which is not facing the G node B, then obviously the performance won't be the best possible. But again, there are plenty of tools that operators do have to advise the end user on which side of the window to mount. So I would say, and to be confirmed, of course, by volume deployment, I would say that 90% plus would be successful.
Yeah. Okay. No, nice number there, Willem. Nice and optimistic, but still, you good confidence. Out of curiosity, ask this person: has the solution been tested on other surfaces which are not properly windows in consumer homes? For example, remote farming greenhouses or in some industrial settings. Actually, we've had one or two other questions around that theme, whether it's your classic, window on the front of your house, or the other surfaces that might work here.
Yeah, well, maybe first on the industrial, we do believe there is a significant use case here for companies. For instance, typical setups is that fiber access to the premises of a company can involve 50-meter trenching into concrete, and having a 5G fixed wireless access for such companies could be very good, or could be very useful. Also backup, quite a lot of enterprises are looking for backup on fiber service, and 5G fixed wireless access is definitely a good solution to that. And if it's easy to install, the better. To the question itself, on the surface itself, you have heard Dan giving the range of distances that we support. And the key thing is that the surface doesn't have flat metal in it. I mean, having a few nails doesn't matter, but if you would have a flat, for instance, an aluminium foil on insulation, then the system will not work. It will detect and it will back off, won't do any damage.
Yeah, okay. Dan, I think you might have had this one, but the same person's come back, and I think a lot of people are thinking it. When did you address when there might be CPE units that people can get hold of for testing, without saying who it is or where? But when might you be able to get a handful of these to run some tests if you're an ISP?
Yeah. So yeah, we currently have some CPE vendors building operator targeted POCs with the goal of having more widely available POCs available in Q1. So early January is the goal currently. So we can certainly follow up and get some requests in our queue.
Yeah. Okay, another one here. I don't know who wants this, but any heat issues on the glass?
I'll take that. It's a very good question, and it's one we've investigated thoroughly. Because of course, with there's the potential that there is heat generation on the window, and does that damage windows? And for I believe it was 3 quarters straight, we had an engineering initiative at the company to try and break a window by applying, increasing power level, increasing heat, doing thermal shock, so heating the window and then throwing cold water on it as the wireless power is affected. We have a bunch of data available on that we'd be happy to share, but the team failed in cracking the window without actually doing mechanical damage to the window. So so to our knowledge, there are no heat issues on the window, and we've tested it extremely thoroughly.
Yeah, okay. Question for either Mayor or Willem. Have you tried 5G FR2 millimeter wave on the outdoor units? Willem, do you want to go first? And Mayor, have you got things to add?
We haven't tested that at this moment, but obviously it would be very easy. One of the reasons we didn't test it is that I don't have FR2 coverage here, but it would be very easy to test. Just a PoE Ethernet connection would do the job.
Yeah, more of it, I guess, mainly US market for FR2.
Yes, I agree with Willem that I think the penetration problem would be worse with FR2, the millimeter wave. And the good thing is with the capacity we have for the through glass data link, we can add up more capacity by increasing the number of antennas, for example. So the data we showed was with the 3x3 Wi-Fi 7 4K QAM, which we could go up to 3.5 gig to match the speed from a millimeter wave deployment.
Yeah. Okay, good stuff. So that brings us to the end of the session. First of all, apologize for my mic. Apparently it was whistling and all sorts. I had no idea. So sorry about that. If you haven't got the slides now, do a refresh and you should be able to get them. If not, I'll ask the Solace team to follow up with you afterwards, where appropriate. If you're a big competitor of theirs, they're obviously not going to, but if you're, in the customer side, I'm sure they'll follow up and share the materials with you. Just remains for me to thank everybody for attending today and for our three speakers from Solace. Starting Willem, thank you very much for being with us.
You're welcome. Thank you.
Maya as well.
Thank you, Gabriel. A pleasure.
Cheers. And finally, Dan Goosens in the marketing role. Thank you, Dan.
Thank you.
Okay, with that, let's just say thank you very much and goodbye.
Goodbye.